I was contacted originally by a good customer of ours in Europe.
They had an issue with contaminated casing, and they went to the OEM, and the OEM told them that they weren't able to refurbish it. What they told the customer is that we can manufacture them, but it's going to be a long lead time. So they called Hydro to see what we can do, if we had a solution.
The only real way of determining if the casing is repairable is for us to send one of our senior inspectors and get their hands next to the pump.
We sent out one of our inspectors to the nuclear power plant in Europe to do a full, very detailed dimensional inspection. So once we've got all that data, the inspection data, our engineering group looked at it and confirmed that the casing could be repaired.
This casing is contaminated. What makes that challenging is there are a handful of contaminated machine shops in the world. And we contacted 3 of them, and after a deep discussion on their method of machining, we felt, although they said they can machine it, it wasn't to our standards.
We contacted a few places. One, our sister company, Hydro East. We had to get their people trained and qualified to work on RAD contaminated equipment. And then number 2 is we had to prepare their shop to accept a contaminated component.
Basically, we were going to create a contaminated machining center in a clean shop.
And the other supplier was our radiation contamination supplier, where we would bring the casing into, and they would transfer their license because their health physics had to be with the casing at all times. Once it was approved, the casing was shipped to Hydro East in Philadelphia. The nuclear plant had a spare rotor assembly that they wanted to assemble this into once it was received back at the plant, but they couldn't ship that into us.
We need to ensure after we machine, those parts still fit inside the casing. Plus, this is a multi-stage pump, so we had to make sure the eccentricity between the stator and the rotors are maintained after the repair. To do that, we needed the parts that fit to the casing.
So what we did while the inspector was out there inspecting the casing, he inspected all the casing rings, the actual casing rings, the diameters that go fit into this casing.
So for that, we had to reverse engineer the mating parts, which gets into the casing, and make some dummy parts to fit inside the casing to measure the fitment and the concentricity between the parts.
When we make the dummy casing ring, we have to account for the gasket compression ratio and assemble it here to make sure everything fit, and check the TIR on the ID of the casing ring.
When we fitted the actual part, when we received it at the decon shop or hot shop, we saw that the actual parts are fitting. So, and the pump has been installed. So it tells you that, yeah, the method we use to eliminate that risk of interchangeability worked out well.
The customer was very happy with the performance and how we did it in such a short period of time.
They, I think, anticipated it will take months.
We worked on it 24/7. We did the project over the course of 6 days, 2 12-hour shifts, and we were on time. Worked out really great.
So they were very happy with the teamwork, and including them. You know, they helped us also with everything, and it was a great team effort throughout.
The regulators were happy, the customers were happy, and we made it possible as a team.
We are a unique company with engineering, contracts, production, management, all close-knit, close working relationships for us to align all of our capabilities in focusing to a successful outcome for the customer. That's what I think is what makes us unique.